now we have read the fundamentals of set. We know that what actually we mean by the term set and the different set operations or the different laws that we can apply on set. So, today we will read the function. First, I give the idea of function. So, with a very simple example, let a car travels with a constant velocity say v for a time t. So, we know the distance travelled by the car, say d equal to v t, since it is a constant velocity. Now, let v is 100 kilometers per hour and the car travels for t hours. Simply we know the distance d equal to 100 t. Now, this equation 1, we know that this is distance is a function of time. Distance is a function of time, that means d is a function of t. Normally we write d is a function of t. What do we actually mean by this? Now, say I take different values of t, since time t is time. So, t can be some real positive number, positive real numbers, real values it can take. So, I take positive real numbers. So, initially I am taking only integer value. Say for t equal to 1, so my d equal to 100. Say for t equal to 2, d equal to 200, t equal to 3, d equal to 300, like that, since it is a constant value, say 100. So, I can get this type of value. Now, see for each t equal to 1, 2, 3, that for this value d is assigned a value 100, 200, 300, like that. So, we can write now that if I draw in this way, as if that this is something called the my time, as if I am denoting the time here, and this is my distance. This is my distance. So, my t can be 1, 2, 3, or give that values, t can take these values 1, 2, 3, this t can take values, and for these my distance can be say 100, 200, 300, like that. So, now if I connect, that means if I give this thing, that it will be a pair, as if it is a pair of T d. this is a pair, this is a TD pair, and that pair will be 1, 100, 2, 200, 3, 300, in that way it will go. That means, this is now if I connect as if 1 and 100 will be connected, 2 and 200 will be connected, 3 and 300 will be connected, in this way it will work. So, this is one example of a function that I can write, that this is a f and it gives you that some t to d. Okay. And see, last day we have read the Cartesian product. Now, if I consider that my all these time values as if this is something one set called x. X consists of all the time values that the car travels, and this is the distance travelled if it is a set x. Then I can tell that this is all the Cartesian product or a subset of the Cartesian product. So, this is a subset of the Cartesian product. So, this is a subset of x cross y, that x Cartesian product y. I can write in this way. So, this is the concept of function. So, now formally we can define function. The definition of function: so, let x and y be two sets. Just now we have with the example we have defined as if x is the set of all real numbers denoting my time, y is the set of values, the distance travelled. Now, a function from x to y, the set x to y is a subset of the Cartesian product x Cartesian product y for each x belongs to x, there is exactly one y belongs to y with x y belongs to f. So, how I define that x and y be two sets? A function from x to y is a subset of the Cartesian product x cross y, such that for each of the element of the set x, x belongs to x, there is exactly one y belongs to y with x y belongs to f. Normally, we denote that f is, we denote like f, the function is x to y. This is my function, and here x is called the domain of f, domain of the function f, y is called the range of function f. Like the previous example that we have taken the t as the positive real numbers. So, when we have considered set x having the values, all values of t's, then the domain is positive real number. Similarly, my d is also the positive real number. So, here domain and range all are positive real numbers. So, now we take some simple example of function. Some simple example of function we see. So, we need two sets. Let the x is only 1, 2, 3. These are the, and y is, I take A, B, C. Now, if I draw the x, so this is my set x and this is my set y. I give only two values, 1, x has 3 elements only and y has also 3 elements a, b, c. Now, normally we represent pictorially by the function as the by arrow diagram. So, we use the arrow diagram. That means, we already have seen the function assigns a value of, for each value of x to some value of y, and that will be exactly one value of y is assigned. So, if I give a arrow diagram, we will draw one arrow from element of x to element of y. Say I give a arrow here, then 1 to a, 2 to b, again I put 3 to a. So, since the function we have defined as a subset of Cartesian product, so here the subsets are, Cartesian product is nothing but the ordered pairs. So, it is 1a, 2b, again 3a. So, this is a function. Now, if I consider say a different type of assignment, again this is x, this is y, say I have 1, 2, 3 and here a, b, c. I give some arrow that say 1 is connected to a, again 1 is connected to b, 2 is connected to c, 3 goes to b. See here this is, it is not a function. So, that means this arrow diagram, it gives that f equal to 1a, then 1b, then 2b, 2c, 3b. So, this is not a this is not a function. Why? See here 1a and 1b, that means that it violates the definition that or the assignment that 1 is connected to both a and b. So, this is for this reason that it is not a function, not an example of a function. Now, we take another example, say again that same x equal to 1 2 3 set and y equal to a b. So, if I take x and y, I take 1 2 3 and this is a b. Then say 1 is connected to a, 2 is connected to b, but 3 is not connected. So, again this is not a function because the definition tell for each x. So, since we do not have here we do not have any connection for 3, we have only the set here f is 1a and 2b, but we do not have 3. So, this is not a function. This is not a function. Now, we have just now we have seen that this is that function last example, that this is a many to one, that means both 1 and 3 is assigned to a, or it can be that only 1 a, 2b, 3c, that type of function can be there. So, for based on their assignments that one value of x is as how it is assigned to another set. So, we can define that the different type of function. So, normally the type of functions are, we have 3 type of functions are there. One is called the one-to-one function. This is a one-to-one. We call it is or injective. We have on-to function, it is called surjective, and one is one-to-one as well as one-to-one and on-to. And onto, and this is called bijective function. Now, we see that how they are different or how their assignments from one set to the other set, that x to y, how they differ. So, first we see that one-to-one function. We see 1 to 1. So, we first give the definition that a function from x to y, a function from a set x to y is said to be one-to-one or what we call the injective. If for each y belongs to y, that means for each element of y, there is at most one x belongs to x with f x equal to y. So, here for first thing is that for each y belongs to y and we have at most one x belongs to x. This is my mapping. So, if I take one example, that say I take the same example of x to y, 1, 2, 3, here A, B, C, as if x is 1, 2, 3, y is A, B, C, and my function is given as if 1a 2b, say 1a 2b 3c. Then if I give the arrow, that 1 is assigned to a, 2b and 3c. That means for each element of y, that means for each value of a, b, c, at most one value is given, okay, at most one. So, if I take the same example, say I have 1, 2, 3, I have a, b, c, then say a is connected to b, 2 is connected to a, and say c is not connected. Then also it is a, because for, if we see the definition, that for each y there is at most one x. Okay. So, here c is not assigned any value. This is, so this is a function. Okay. C is not connected or assigned. But if I take this type of example, so it is a function, but it is not a one-to-one function, not a one-to-one function. Is not a one-to-one function. So, what is the condition to be satisfied for a function to be onto? The condition to be satisfied for a function to be onto one-to-one, first one-to-one, I write that for all x 1 and for all x 2, if I consider two values, then f of x 1 equal to f of x 2 implies x 1 equal to x 2. This must be true. That means, if I get some f of x 1 equal to f of x 2, then x 1 must be x 2. That previous example we have seen. So, this must be, this is the condition to be true. So, if it is not a 1 to 1, if it is not a 1 to 1, then the above condition must be false. If I give some number, that the condition 1 must be false. So, if I take the negation of that thing, if I take, then that negation must be true. Negation must be true. If it is not 1 to 1, not a 1 to 1 function, then if I apply the negation rule, then I get there exists x 1 and there exists x 2, and this is negation of f of x 1, and if I remember that negation p to q, that means negation p or q, this is equivalent to p and negation q, because negation p or q. So, this is p and negation q. So, directly I can write that f of x 1 equal to f of x 2 and x 1 negation x 1 equal to x 2 means x 1 not equal to x 2. So, this is the condition we have to show, or this is the condition that we can, if it is true, we can show that the function is not 1 to 1. So, whenever if and problem is given, we have to show that the function is 1 to 1, then we have to show equation 1, and if we have to show that function is not 1 to 1, then we have to show this thing. That means, there exists x 1 x 2 for which f of x 1 equal to f of x 2 and x 1 not equal to x 2. So, if we take one example, that we see, say prove that 2 to the power n minus n square, so f of n equal to 2 to the power n minus n square is not a 1 to 1. So, not 1 to 1, then we have to show that f of x 1 x 2 and x 1 not equal to x 2. There exists some value, there exists some x 1 and x 2. So, now if I take that n equal to 2 and n equal to 4, because I have this is x 1, n equal to 4, some I have x 2 say. Now, what is f 2? F 2 is 2 square minus 4 is 0. I have f 4 is 2 to the power 4 minus 4 square is 0. So, what we see that f of x 1 equal to f of x 2 and x 1 not equal to x 2, that 2 not equal to 4. So, that means it is not a 1 to 1, not a 1 to 1 function. Okay. Now we see that our onto function, we define my onto function that simply that if function f from x to y is onto if the range is y, and it is called the onto function is called the surjective. It is called the surjective. And what is the condition to be satisfied? Condition is, so for all y, that y belongs to y, because this is my range, there exists x belongs to x, I get that f of x equal to y, and this is the condition to be satisfied, that the function to be condition that the function to be onto. And if the function is not onto, like the previous one we have done, that we take the negation and it will be that there exists y, then belongs to x, for all x belongs to x, negation of f x equal to y. So, f x not equal to y. So, there must be at least one x, at least one y, that means it is not the range. We remember the range is the set of y, range we call the set, range is the set y. So, at least one element y exists for which f x not equal to y, and then that means it is not onto. And if I define that our bijective function, if a function is 1 to 1 as well as onto, 1 to 1 and onto, then the function is, then it is a bijective function. So, we have read the basic concepts of function and the three different type, that mainly the injective function, surjective function and the bijective function, and some simple examples that how or what type of function it is, and how to show that if it, what are the conditions to be satisfied to show that if it is a bijective or if it is a injective or if it is a surjective. So, bijective, the two conditions must be added. This is a conjunction of the two functions, two conditions of bijective onto functions and the one to one functions.